Should we care about our microbiome? Ideally, we'd have clear evidence showing that we're healthy when we have a healthy microbiome. Our biome gets disrupted, and now illness occurs. And then, by getting our microbiome back in shape, the health problem resolves. Unfortunately, we don't have this type of evidence for most of what folks say about our microbiome. Promising? Yes. Settled? Much less so.
Hi, I'm Dr. Bobby Du Bois, and welcome to Live Long and Well, a podcast where we will talk about what you can do to live as long as possible and with as much energy and vigor that you wish. Together, we will explore what practical and evidence-supported steps you can take. Come join me on this very important journey, and I hope that you feel empowered along the way. I'm a physician, Ironman triathlete, and have published several hundred scientific studies. I'm honored to be your guide.
Welcome, my dear longevity-oriented listeners, to episode 36, the microbiome, the fountain of health, or we just don't know. Well, if you read headlines, and I certainly do, they tell us that the microbiome critically determines our overall health, whether we have inflammatory diseases, whether we're going to lose weight, get diabetes, heart disease, depression. Now, is that proven? Well, let's try to sort through the evidence together. And there are a few questions that I think frame that dialogue. First, is our microbiome important to us? 2, does our microbiome change or get disrupted by things we do or things that we eat? 3rd, does an altered microbiome lead to disease? Or is it just an innocent bystander and it is not the cause of the disease? And 4, can we treat the microbiome and those diseases get better? Well, what are the answers to these questions? Yes, the answer is that the microbiome seems to be so important and changing it can improve our health if you're a certain type of genetic mouse. But for people, it's less clear. Well, as my dear listeners know, I try at the beginning of each episode to explain why now? Why are we talking about this topic now? And as my listeners know, I typically focus on areas where the evidence is pretty clear, either pro or con, but it's pretty clear. Are there evidence-based approaches to improve sleep? We've talked about that. Of course, the answer is yes. Does exercise lower our risk of heart disease? Yes. Is coffee good or bad for you? Listen to my episode and you'll be reminded what I thought there. And the converse. There's no evidence that I could find to support the urban myth of 8 glasses of water a day. So, up until now, all of the episodes I've done now, I've avoided topics where there really isn't a clear answer from the evidence, like the microbiome. Or I haven't talked about artificial sweeteners or stem cell injections into our joints or peptides or fluoride in the water. And I've generally felt up until now that, talking about these topics really might not be very helpful for you because there isn't a straightforward answer. But then I realized, and you, my readers, have sent me lots of requests for topics. I realized that if I'm uncertain about these topics, then obviously many of you would also be uncertain. So what I do bring to the table is an ability to look at the evidence. And maybe it'll be helpful to you for me to summarize the evidence and tell you what we know and what we don't know, even if we don't solve the fundamental question about the importance of a microbiome or fluoride or whatever it might be. As always, I try to be an unbiased observer on these topics. Now, we all have biases. I have a bias. When I think about how I approach new topics, I like to think of myself as sort of an open-minded skeptic, meaning I don't jump in and assume it's all true, but I'm open-minded about that topic. So for my own case, the microbiome, before I began this journey, I was a bit skeptical. But I was open-minded, and after reading a lot of evidence and summarizing, I have definitely become more intrigued about its importance. Am I convinced? In some areas, yes, but in most areas, not quite yet. Well, I'm not going to know whether this helps you without you letting me know. I have a questionnaire that will ask you just a few questions about my podcast. Please go to it, answer it. I've added a new question that relates to these type of more uncertain topic areas. Let me know what you think about it, because otherwise I really don't know how I can best help you. Okay, time for the microbiome backstory. Well, the claims about the microbiome and its importance in health and in disease are remarkable. You know, the implication is if we could only just fix our microbiome, you could cure inflammation and lose weight more readily, not have diabetes or other kinds of things. Now, it isn't just headlines. There are over 250 companies really focused on the microbiome. There are tens of thousands of scientific studies. Of course, I went to the expert, which is Amazon, and asked how many books are there. Now, Amazon in its summary doesn't say how many books once it's beyond 1,000, but there's at least 1,000 books on the microbiome that are indexed in Amazon. And there's at least over 1,000 supplement choices. Again, they don't tell me if it's 5,000, 10,000 or more. There's lots and lots of excitement about this. There's lots of studies. But as we'll find, almost all of the work has been in the laboratory or in animals, where in these animals, we might artificially create an abnormal microbiome. And bad things seem to happen to the animals. They get sick. And then for those animals, we give them a good microbiome, and things seem to get better. But, you know, mice are not people. Well, in this uncertain topic area, I will do my best to tell you what seems to be convincing and what may not yet be. Well, we need some background information about what is the microbiome so that we're all on the same page as we sort through this. We have trillions of bacteria that are just sitting around in our mouth, our nose, in women's vaginas, and in the gut. And the gut has received the most attention. It's also all over our skin. Most of the discussion of the GI tract and the microbiome is focused on bacteria, but the microbiome also has viruses and fungi and parasites. So that's a piece of this puzzle, although we know less about that. A lot of the excitement about the microbiome is the vast quantity of it. There's more bacteria in our microbiome than there are cells in our body. How can we just ignore that number of things in our body? And if you add up all the genetic material, that information in each and every one of those bacteria, it's perhaps 100 or 150 times more genetic information from those microbiome bacteria than there are in our own body. There are thousands of species of bacteria in our bodies. And as the research goes, that if we have a healthy gut, if we are doing really, really well, we have many, 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 many types of those bacteria in our GI tract. There's diversity. Now, I will point out, it does not appear there's such a thing as an optimal microbiome. We all differ. It's not like blood pressure or cholesterol, which I can tell you, this is a safe number. This is where it starts to get more risky. We honestly don't know what the perfect microbiome is. And we each have our own profile, and it changes over time. And it varies by location. Our small intestine has certain sets of bacteria. Our large intestine may have different, and that diversity may change as we get older, especially after age 70. People talk about some of the bacteria, lactobacillus and bifidobacterium, and that these are good bacteria to have. And there's now excitement about a bug called Akkermansia that is hard to grow in the lab, and that's why we didn't know it was around as much as it is. So a lot of excitement there. Initially, when we're developing in our mother's uterus, we don't have a microbiome. But as we get delivered through a vaginal approach, we pick up the microbiome from our mothers. If you have a C-section, you don't quite get that, and there's some question about what that does for us and the development of the young baby. So what does the microbiome do, or what do we think it does? And I'll focus for the moment on that predominant thing, which are the bacteria. Well, one of the things your microbiome bacteria do is they help us to digest food. Think of a yummy piece of broccoli, and especially the really starchy, cellulose-laden stem. That's hard for our normal stomach acids and acids in our intestine to break down by itself. Those fibers, those starches, those complex carbohydrates need help. And the microbiome bacteria help us to digest that. So if we didn't have a good microbiome, we might not be able to break down some of our foods and get the nutrients from them. It's also a protection scheme. Imagine having soldiers that fight off invaders. Well, good bacteria in our microbiome help, as the theory goes, to fight off bad bacteria. So if you have a healthy microbiome, you can resist some of these pathogens and disruptions. Also, the microbiome bacteria help us to synthesize certain vitamins, certain B vitamins and K vitamins that otherwise we might not have. So we're very thankful for them for doing that. And the microbiome in our GI tract helps in the development of our immune system. And it may have something to do with changes in our immune system over time. Well, I want to at least mention a few terminology elements because we hear about them and we often get confused. So the probiotic, when you hear people say you should take probiotics, that's giving the good bacteria. So if you have yogurt or pickled vegetables or kombucha or kefir or sauerkraut, that is full of some of these bacteria. And so that's why you'll often hear that this would be good for us to eat on a regular basis. Or you might hear about supplements that contain capsules of these type of bacteria. So that's a probiotic. A prebiotic is basically giving your bacteria the right food. So if you eat pectin and indigestible carbohydrates like whole grains and beans and certain fruits, that may help our microbiome as a prebiotic because we're giving food to those bacteria. Now, it also might increase gas that develops, but it also helps those bacteria. Then there's something called postbiotics. Now, these bacteria may produce certain compounds that could be beneficial. So a postbiotic is giving those compounds that might help us as well. So this is what's supposed to happen when you have a happy, diverse microbiome. But obviously, we're having this topic because we think it has something to do with disease. So now let's think a little bit about disrupting the microbiome. So first, we've talked about the happy microbiome and some of the things it's doing for us. But that biome can get disrupted. And that has a fancy name, which is called dysbiosis. So you may have heard the word dysbiosis, but it's just a disruption in the microbiome. And when that happens, the bacteria change. You get more of this type, less of that type. The diversity of having lots of different types of bacteria may lessen. Well, there are various things we know that can disrupt your microbiome. Things like antibiotics and laxatives and certain hormones and certain other drugs, proton pump inhibitors and the like. But other times, our microbiome changes and we're not exactly sure why. Is it something we ate? Was it additives in certain of our processed foods? Is it just bad luck? Or is the microbiome changes, is it due to other diseases of the body? So here is the crux of so much of the discussion and controversy. Do changes in the microbiome, which as we'll talk about, really, really do occur? Does that lead to the disease? And the converse, if we can reset the microbiome, will it cure the diseases? So our last episode, we talk about flossing. And I made the argument that oral health, which is related to bacteria and things in our mouth and gums, might be related to heart disease. And as I mentioned, is it that the bad bugs or the change in the bugs or the bugs that can get in our body from injured tissues in the mouth, does it cause the heart disease? Or is there a common link, like smoking? Smoking causes heart disease. Smoking also disrupts our mouth health. So is it the bad bacteria getting in our body causing heart disease? Or is it something else that just the changes we observe in the bacteria is an innocent bystander? That is the critical question. And as you've heard me and others say, correlation is not causation. So seeing a disrupted microbiome in people with diabetes or MS or other things doesn't mean that disruption caused the disease. And if it didn't cause the disease, then improving your microbiome may not affect the disease by very much. This is the crux. Is it the causative factor or is it just an innocent bystander? And it's so important because if it's the causative factor, then we want to protect our microbiome. And when our microbiome gets unhappy, we want to help it get back to being healthy. That's the crux of this. So as I said, when I began my journey of looking at the evidence here, I began with some skepticism. But as I read more, some of which I already had known, but some of which I obviously learned anew, there are definitely areas where I am convinced the microbiome is front and center, causes the problem, and we can make it better. But I'll then get ourselves into the areas where the evidence, frankly, isn't so convincing. So let's begin with where I think it's really solid that the microbiome is at the center of a health problem. And that's in a colon infection, or large intestine, called C. difficile, Clostridium difficile. Sometimes these bad, evil bacteria take over in our colon. And when that happens, it causes colitis or inflammation of our colon. This often typically happens after patients have been given antibiotics, often in the hospital where these are really strong antibiotics, and they wipe out all the good bacteria in our colons, and the bad ones, the C. difficile ones, take over. This is a really big deal, and it has a high mortality. From 6 to 30% of people historically who got C. difficile colitis died. And there's been a tremendous amount of excitement around what are called fecal transplants. Now, it probably sounds kind of like what you think it is, which is you're going to take stool or the elements of stool from a healthy person and put it into people who have this infection. Or sometimes they even collect it from you before you go to surgery and have big antibiotics, so you're ready if you need this transplant. And it turns out these fecal transplants, which is putting good bacteria back into your system, has an 80 to 90% success rate for this C. difficile colitis. So you're improving the biome, and it fights off those bad bacteria, and people get better. And this is getting to be very well accepted. Specialty academies, the groups that license and certify certain doctor specialties, they are supporting this. So I would say the evidence here is really strong, really convincing for this one area. But is there convincing evidence in other areas? There's been a tremendous amount of focus on weight gain and weight loss, and whether our microbiome might determine whether we're likely to gain weight or whether we might be able to stay skinny. Now, I would say there is compelling evidence, but there's compelling evidence if you're a mouse. So there's been a whole series of really exciting, what I call fat, skinny mice studies. And what do? Well, they take obese mice and take the poop from the obese mice. So you're getting the microbiome, the bacteria, and you give it to skinny mice. And lo and behold, the skinny mice get fat. Well, conversely, if you take skinny poop and give it to fat mice, the fat mice get skinny. Wow, this is amazing. And if you take the poop from obese humans and give it to the skinny mice, lo and behold, they get fat. But when you try this in people, and it has been tried in people, and you give skinny poop elements to obese folks, it doesn't change their BMI, their weight. So this is typical of the microbiome field, and it's why I've sort of tended to avoid talking about it in other topics like this. The mouse information is fascinating, but it either doesn't work in people or it hasn't really been tested in people. And to make matters even worse, these are not normal mice. Because you might say, well, it works in normal mice. It might work in normal dogs. And if it works in normal dogs, it might work in chimpanzees and then in people. But these are not normal mice. These are genetically and specially raised mice that really begin their life with no bacteria in their guts. These are like a blank canvas. So I think this is an extraordinarily exciting set of data, but do I think it applies to humans? At the moment, I can't quite see that it does. We'll learn more. Maybe people will try new approaches. Maybe it'll work. Okay, so we've talked about the colitis. That seems to be important. The fat, skinny mice, important for the mice. Let's go on to some other diseases where there's a lot of discussion around the microbiome. And that is immune diseases, inflammation diseases, things like ulcerative colitis or Crohn's disease or rheumatoid arthritis or multiple sclerosis. So we do know as babies are developing, you have immune cells in our intestines, and they help develop our immune system. And as you get older, these parts of our intestine produce antibodies and certain types of cells, T cells. And we know that if there's dysbiosis, if there's disruptions in our biome, microbiome in our intestines, that immune development might be affected. And so here's one of the theories or mechanisms. Now, mechanism isn't evidence of what happens. It just gives us a theory. So if you have a good biome, some bad compounds that get into our intestines may not be absorbed. But if you have a bad biome and you can't protect yourself, some of these compounds can injure your intestines. And when the intestinal wall is injured, some of those bad things can get in our bodies and raise inflammation, blood things that we could measure, like C-reactive protein or interleukin-6. And these things that get in the body and cause these changes in our markers might cause inflammation. So that's the theory. Theory's great, but what do we know in people? Well, if you have ulcerative colitis or Crohn's disease, and so you have really bad inflammation in your intestines, and it causes really severe disease, both in your intestine and sometimes in the rest of your body, that when we find these people and we look at their microbiome, they're often disrupted. They often have changes that seem to be a problem. But as I said earlier, does one cause the other? Is it that disrupting the microbiome at some level causes us to develop, or at least maybe those of us that are genetically predisposed, to get ulcerative colitis or Crohn's disease? Or does that disruption of the intestines, for some reason we don't really understand, does it change the microbiome? So the microbiome is just sitting there and reflecting the disease, not causing it. Because, of course, what you'd like to find is if it's causing the disease, then we can treat it. Treat the microbiome, treat the disease, people get better. So there have been studies of giving probiotics to people with ulcerative colitis and Crohn's disease, and a meta-analysis or a summary of 9 studies where they did this. They found, on balance, it didn't help people with Crohn's disease. So with Crohn's disease, maybe the microbiome isn't causing the problem, and solving the microbiome may not solve the problem. But for ulcerative colitis, there are some people who seem to get some benefit. So it was inconsistent, but maybe in the future it will be more effective. Well, what about multiple sclerosis? Here, too, the microbiome seems disrupted. There are some interesting animal studies. There's one small study in people which showed a little bit of benefit from taking probiotics. In rheumatoid arthritis, there's been a meta-analysis of 9 studies, only 360 total people. So these are really tiny studies. And they found that probiotics might improve some of the markers of inflammation. So the blood tests got a little bit better, but it didn't seem to change the symptoms. So changing the blood tests, but not changing the symptoms, I'm not sure how helpful that is. Well, what about diabetes? A lot of focus on diabetes. Yes, if you take the microbiome of people with diabetes, it looks different. It absolutely does. And sometimes it looks like that disrupted or changed biome is associated with worse blood sugar control. But it's always the same question. Where's the chicken and where's the egg? Which causes which? So in animals, probiotics can improve the microbiome of the animals, and it does seem to improve blood sugar control. But in people, we really don't know. There was a tiny, tiny study of 9 people where they took the microbiome of lean people and gave it to those who were overweight or had metabolic syndrome. And they found that, lo and behold, they could improve the microbiome, give it back its diversity. And there was some improvements in insulin sensitivity, but will it treat the disease, treat the diabetes? We just don't know. There was a systematic review, summary of 33 clinical trials on probiotics for people with diabetes. Some showed some improvements in blood sugar, some showed some improvements in blood pressure, some showed some improvements in cholesterol levels, but it was really inconsistent. And no study showed improvements in all these different key areas. Now, does this mean that the microbiome isn't going to help us for diabetes? That's possible. It's possible that we really don't have a connection like we think. But we may not have shown the benefit because the studies aren't very high quality. They're often very tiny. And when you give people probiotics, it's not like giving a statin where we know exactly what you're receiving and what dose. The microbiome replacements, the probiotics, it's a mishmash of different things. So it's not a standardized therapy. So maybe we're not seeing the benefits that are possible because the therapy isn't standardized. But when I take a giant step back, so maybe the microbiome and treating it could help our diabetes. Yes, it might, but at this point, it's tiny amounts. It's not going to replace your metformin or your Ozempic or other kinds of things. And there is some data that suggests, well, maybe as an addition to regular diabetic therapy, changes to your microbiome, probiotics might be helpful. Okay, let's step back and summarize. There's a lot of excitement in this area. There's really compelling animal data, especially in mice. And there's lots of data that when you have certain diseases, the microbiome is disrupted. And there's only, though, a small number of areas where changing the microbiome back to something that looks more normal makes a big difference. And we talked about the C. difficile colitis. And maybe there's some interesting data in many of the other areas. A lot of it is in animals. Okay, so the risk is low. What's the harm in eating some more fiber and fermented foods? It sounds good. It's not going to hurt you. And maybe it will help. So why not? But keep in mind that the benefits so far, although there is possible there are some benefits, it's not going to replace traditional, effective, proven therapy for your rheumatoid arthritis or your Crohn's disease or your diabetes. So it may be something to do. It may help the disease, but it probably at this point isn't going to solve the problems. And of course, the key question for all of us is if we maintain a healthy biome by eating good foods and things like that, will it help us avoid getting chronic disease? This is the ultimate question, but it's the ultimate question I did not find an answer to. It's an intriguing area in general. It's evolving, and I'll follow it closely, and as key information comes up, I'll share it with you. Well, do I feel good when I eat some yogurt? I do make homemade yogurt. We can talk about that another time, which is way better than store-bought. Do I eat sauerkraut and feel good about it? Yeah, I do, but it isn't something I require myself to do every day. I am certainly not rushing out and buying expensive probiotic supplements. But it might be helpful in some cases. It's certainly simple to do. And if you like those foods, even better. Well, before we say goodbye, did this type of episode work for you? Please let me know. Send me comments. Take that questionnaire that's a link in the show notes. Let me know if episodes where we don't really have a simple answer, whether you like them, whether you're actually listening to them, or you shut down and turn it off and go to some other podcast fairly quickly. So with all of that, I enjoy diving into topics and sharing them with you. I hope you get something from it. And with some feedback from you, I'll know whether to do more topics like this in the near future. So take care. Enjoy your microbiome. Have your yogurt or your sauerkraut if you wish. It can't hurt, may help. Stay tuned for more evidence.
Thanks so much for listening to Live Long and Well with Dr. Bobby. If you like this episode, please provide a review on Apple or Spotify or wherever you listen. If you want to continue this journey or want to receive my newsletter on practical and scientific ways to improve your health and longevity, please visit me at drbobbylivellongandwell.com. That's doctor as in DR, Bobby, livelongandwell.com.